Hello everyone, today I'll be solving or giving hints to the first problem in assignment D. So the first problem reads as follows. Consider that there are two magnetic dipoles, one located at the origin, the other located at y is equals to z is equals to a. The magnetic dipole moments are given by uh, m1 which is equals to m1 z cap and m2 which is equals to m2 y cap plus z cap by square root of 2. Uh, what is the torque exerted by m1 on m2? So to find the torque, and then also we have to find out if the torque on m2 tend to rotate m2 in the clockwise or counterclockwise direction. So to find the torque on on M2, to find the torque on M2, basically torque on M2 is equals to the dipole moment of M2 uh, cross product of dipole moment of M2 with the magnetic field on M2. Okay, now this magnetic field is uh, due to M1, so let's call this 1 2. Okay, so uh, magnetic field. So B12 is the magnetic field, okay, uh, due to the dipole M1 on M2. Okay, so basically we have to find out the torque. To find the torque, this is the cross product that we have to do. But to do this cross product, we need to know B12. Uh, from the textbook, okay, from the text, the formula, uh, from the text, the formula for magnetic field, okay, due to a dipole is given to be equal to mu naught m by 4 pi r cube multiplied with 2 cos theta r cap plus sine theta theta cap. Okay, so this is given on page 255, section 5.4, chapter 5. Okay, on the Griffiths textbook. On the Griffiths textbook. So please go through this formula. I'm assuming the formula is derived in class or it's been given to you as a known value. Okay, so therefore B12 is equal to mu naught uh, m1. Okay, the magnetic field is due to m1, so therefore we use m1 in the numerator. 4 pi r cube 2 cos theta r cube plus sine theta theta cap. Now what is the value of r and what is the value of theta? Okay, so r is the distance of separation between m1 and m2. So we see that m1 is located here, m2 is located here. So we know that m2 is located at a point where y is equals to z is equals to a. So this becomes a and this becomes a. Therefore r, you can find out the value of r using Pythagoras theorem. Okay, find out the value of r using Pythagoras theorem. uh, Again, m1 and r both are scalars in this equation, so you don't need the direction for it. The directions are covered here. And then theta is the angle um, made by, I'll erase this, I'll leave it for you to find out what theta is. Now theta is the angle made by m2 with respect to the z axis. So if one side is a, the other side is a, uh, I mean, yeah, if this is theta, if this is a, then you have already found out what r is using Pythagoras theorem. You can find out what theta is using the simple cosine or sine formula. Okay, from trigonometry. now. So once you find r and theta, substitute those values here and find out the value of b12. So b12 now is basically uh, a vector in spherical coordinates. Okay. Solution. You'll get a spherical coordinate solution for b12 because this is all in r and theta cap. Now, the next step is to find out the cross product, okay, n2, which is equals to m2 cross b12. Now, we know that m2 is equals to m2 vector is equals to m2 multiplied with y plus z cap by square root of 2. Okay, so this is in Cartesian coordinates. However, b12, you'll find that it'll be some value, okay, which is mu naught m by 4 pi r cube. So substitute the value of r and theta and find the simplified formula here. 2 cos theta r cap plus sin theta theta cap. Okay, this is in spherical coordinates. Okay, now so we cannot do the cross product until both of them are on the same coordinate system. So we convert m2 from Cartesian to spherical. How do we do that? Refer the last page of the textbook. Refer the last page of the textbook where the formula for conversion of, so y cap is equals to sine theta sine phi, okay, r cap plus cos theta cos phi theta cap plus cos phi phi cap. Okay, so I'll release this. This is the conversion for y cap and this is the conversion for z cap, cos theta r cap minus sine theta theta cap. Okay, so this is the conversion from Cartesian to spherical. Okay, this formula is available at the end of the textbook. So your job is to find out what theta is, what phi is. I'll give you a hint as to how to find those values. So you would have already found out what theta is because theta is this angle. Okay, now theta is this angle. Now if this vector is projected onto the xy axis, okay, xy axis, then the angle it makes with the x-axis is the phi. Okay, in this problem, this vector, however, is completely located in the yz plane. Okay, so then what would its projection on the xy plane look like? Okay, where will it be? Will it be here or will it be on the y-axis? So if it's on the y-axis, then what would angle phi be? Okay, so that's the hint to find out what phi is. So you would have found out what theta is from the previous part of the problem. You find out what y phi is from here using this part, and once you do that, you pretty much have converted m2 into spherical coordinates, and then all you have to do is basically perform the n2 is equals to M2 cross B12, do the cross product using r cap, theta cap, phi cap formula. So whatever M2 has, um, whatever M2 has as its r component, whatever M2 has as its theta component, if it has one, whatever M2 has as its phi component, and again B12 r component, B12 theta component, B12 phi component. Okay, I'm not saying all of them exist. I'm just saying write it down in this way and find out the cross product. So that will give you the final torque on the dipole M2. Now the last question uh, is whether the torque tends to rotate it clockwise or counterclockwise. Uh, you can answer that question. You can answer that question once you find out what is the direction of the torque. Okay, so if the direction of the torque is let's say so yeah uh, so the torque direction um, i- torque direction is going to be uh, so if this is the direction of the torque, then the direction of the torque is like this. If this is the direction of torque, then it's like this. So then the clockwise is, so if the direction of the torque is along the negative x direction, then it's clockwise. If it's along the positive x direction, then it's the anti-clockwise. Okay, so this is convention. Basically the direction of torque is always the outward, uh, is the direction of the finger when you curl the fingers around in the torque direction. So okay, so the fingers tell you the rotational motion, then the if the curling fingers tell you the rotational direction, and the thumb finger tells you the direction of the torque. Okay, that's it. Thank you.